All right, 7th graders, we are in the last section of Chapter 5. This covers number patterns. So we're going to talk about sequences today, number patterns. Now, I just want you to listen to this scenario. Let's say that you are in a city, and you notice that the first 3 streets you pass are 10th Street, 11th Street, and 12th Street. What would you conclude that the next street would be? If the first 3 streets are 10th, 11th, and 12th that you see, what do you think the next one is? Probably 13th. That is using something called inductive reasoning. You're making a conclusion based on inductive reasoning. Now, inductive reasoning is making conclusions based on patterns you observe. So a pattern that you observe, and then you make a conjecture or a conclusion based off that, you are using inductive reasoning. A conclusion that you reach by inductive reasoning is called a conjecture. So inductive reasoning is the process of making a conclusion based on patterns you observe, and the conclusion that you make is called a conjecture. All right, so I'm going to give you 2 number patterns. The first number pattern is 2, 5, 8, and 11, and the next one is 2, 4, 8, and 16. I want you to find a pattern. Use inductive reasoning to describe the pattern. So what do you think the pattern is on A? Hopefully you notice that you're increasing by 3 for each number. You just found a pattern. Now, using that pattern to find the next 2 terms. What would the next 2 terms be in this pattern? Well, if we add 3 again, it's going to be 14 and then 17. So you just use inductive reasoning to make a conjecture. So B, what pattern do you see in B? The pattern is multiplying by 2. If we multiply the previous term by 2, the next 2 terms would be what? They should be 32 and 64. 1, 4, 9, and 16. Find the next 2 terms in the sequence by finding a pattern. Pause the video and see if you can do it yourself. Hopefully you realize that these are squares. So we're squaring consecutive integers. So you do 1 to the 2nd power, 2 to the 2nd power, 3 to the 2nd power, 4 to the 2nd power. So the next one would be 5 to the 2nd power, which is 25. And the next one would be 36. These are all perfect squares. So 4, 9, 16, 25, 36, they're all perfect squares. So the next thing we're going to do is we're going to write rules for arithmetic sequences. So, first vocab word, a number pattern. A number pattern is just called a sequence. Each number in that sequence is called a term of that sequence. One kind of sequence is called an arithmetic sequence. There's a vocab word. You form an arithmetic sequence by adding, important, adding a fixed number to each previous term. This fixed number is called the common difference. So let's look at the arithmetic sequence -7, -3, 1, and 5. What are you doing from one number to the next? You're adding 4. So we found the pattern, but now I want you to find the common difference. What is the common difference? The common difference is 4. The next sequence we're going to do is 17, 13, 9, and 5. Now, some of you may think, well, wait a minute, I thought the arithmetic sequence was adding a number. It is. What do you add to 17 to get 13? You add a -4, which is the same as subtracting 4. So you subtract 4 each time, which is adding -4. So the common difference here is going to be negative 4. So I want you to find the common difference of this sequence. What is the common difference? The common difference would be negative 5. All right, so let's step it up a notch. I want you to consider this sequence: 7, 11, 15, and 19. What I want you to think of is this, and this is important. This is going to be a little different. You want to think of all 4 of these numbers, each term, as the output of a function. So I want you to think of it this way. I want you to think of like the first number in the sequence, the second number of the sequence, the third number of the sequence, the fourth number of the sequence. So the first term in the sequence is 7. The second term of the sequence is 11, 15, and 19. I want you to think, as are these values, the term number, as the input, that's your x, and these numbers as your output. Now that would also mean this would be domain, this would be range. Domain is your input, range is your output. Now, you can use the common difference of the terms of an arithmetic sequence to write a function rule for the sequence. A function rule, remember, is an equation. So we're going to write an equation for the sequence. Now, this is important. We always have to know what numbers we're going to use. Now, you can use x and y, you can use whatever you want. I'm going to use n as the term number in the sequence. I'm going to let a of n, which is your output, represent the value of the nth term of the sequence. So that would mean this. The first term of the sequence would give me a value of 7. The second term of the sequence would give me a value of 11. The third term of the sequence would give me a value of 15. And the fourth term would give me a value of 19. So what would the nth term of the sequence give me? This is your function rule. Here's where the part comes into play. You have to think what's happening. So we're going to go back here. This is 7. This is going to be 7 plus 4. This is going to be 7 plus 4 plus 4. This is going to be 7 plus 4 plus 4 plus 4. Now, this is where it gets a little even harder. If you take the 7 of your original sequence, we don't do anything with that. How many 4s do you have here? Let me actually make a new page to make this a little easier for you. All right. So you should notice that in the second one, we have 7 plus 1 times 4. In the next one, we have 7 plus, we have 2 times 4. In the next one, we have 7 plus 3 times 4. What's changing each time? These are changing. Everything else stays the same. So that means if we write a function rule, we can write it like this. The 7 stays there. The 4 stays there. Now let's look at your relationship. When you plug in the second number of the sequence, you get 1. When you plug in the third number of the sequence, you get 2. When you plug in the fourth number of the sequence, you get 3. So what are you doing with n, the number of the sequence? you're subtracting 1. 3 minus 1 is 2. 4 minus 1 is 3. 1 minus 1, there's 0. There's none there. So your actual equation, or your function rule, would be 4 times n minus 1 plus 7. You could also write it like this above it as well. But there's your function rule, which leads into our key concept. Here's your key concept, and this is for an arithmetic sequence A. An arithmetic sequence. So here we go. Here's your rule. A of n equals A plus n minus 1 times D. Now you're like, oh my gosh, what is all this stuff here? This right here is the nth term of the sequence, which means it's a function rule. It's a rule that works for any term of the sequence. It's the name of the function. This term, the A, this represents your first term. Notice in the problem we just did, the first term was 7, so that this is 7. And then we have plus this. And let me erase that. I meant this right here. The n represents the term number. And lastly, the D represents the common difference. Notice the common difference in the problem we just did was 4. We added 4 every time. So this is your formula you must memorize. Let's make a super duper giant star. Oop, that's too big. Make sure you know this. Know this, know this, know this. Let's make an arrow too. You got to know this. In example 3, we're going to find a function rule. So the function rule, let's find the sequence 15, 20, 25, 30, and so on. Write a function rule. So the first thing we do is A of n equals. What goes first? Look at your formula. What goes first? The first term. The first term is 15. Plus n minus 1 times the difference. What's the difference? What's happening each time? It's going up by 5. So our common difference is 5. So this would be your equation or your function rule written for the arithmetic sequence. All right, so our last example. Find the 10th term of the sequence. Well, the 10th term means I'm going to take A of 10 because that's the 10th term. Equals 32 plus, I plug in 10 minus 1 times negative 2. So now you just simplify. A of 10 equals 32 plus 9 times negative 2. That would give me A of 10 equals 32 minus 18, which would give me the 10th term of 14. So the 10th term, notice how I wrote this. You must write it like this. The 10th term of the sequence, and the arithmetic sequence, that's why it's A, is going to be 14.